Hey everybody, welcome back to a new video. Today I'm excited to show you guys a new power station. This is the FossyBot 2400. This is a really affordable model, and if you're looking for your first large power station, this one is very beginner friendly. Not only is this power station easy to use, but it also checks off a lot of the boxes that my viewers are looking for. For example, this does have lithium iron phosphate batteries. It's rated at 3,500 charge cycles. It also has a massive inverter at 2,400 watts. So basically any appliance that you have in your house, you basically can plug it into this and it's going to work just fine. It also has internal fast charging. You can charge up to 100% in less than 2 hours. But if you want to slow charge it, you just turn down this knob on the front to adjust the slow charging. This also acts as an uninterrupted power supply with a swap over time of 8 milliseconds. So it works really well as a home backup. And my favorite feature, the DC output on the front, there's an XT60 port that's rated for 25 amps output. Now this power station has many different use cases. For example, if you wanted to take this camping and have the most luxurious experience ever, power all of your devices, this will definitely do that. This also works really well as a home backup solution if you have an extended power outage to keep your full-size fridge running, or if you wanted to take this along with you on your RV or a trailer or even a van life scenario to power all of your cooking and refrigeration needs, this would definitely do that as well. Now there are multiple bundles on Amazon to purchase this. The one that sticks out to me is the power station by itself. It comes in at $1,400, but there's a $200 off coupon right now to bring the price down to $1,199. Now in the rest of the video, I'll be showing you all the extensive testing that I did on the power station to show you guys how it truly performs so you guys can know the facts about the FossyBot 2400 and if it's the right power station for you. Now here on this side of the power station, you lift up this flap and it exposes 6 AC outlets. This is where the AC inverter is. Remember, it's advertised to be a 2400 watt pure sine wave inverter. So let's go ahead and jump into the testing results on the AC inverter. One of the best use cases for a larger power station like this is to run your full-size fridge in the event of a power outage. I wanted to see if the F2400 could keep my full-size basement fridge running for 24 hours straight without a charge. And checking in 28 hours later, the state of charge was at 12%, so this did run my fridge for over a day without an issue. Now just be aware, you could also get a longer runtime by charging off a gas generator or by plugging in up to 500 watts of solar panels. The FossyBot also has the ability to act as an uninterrupted power supply or a UPS. This means that when you have the power station plugged into a wall outlet, it can bypass up to 1100 watts straight through the power station to your devices. If grid power goes down, the power station will automatically swap over to the batteries inside within 8 milliseconds. This is one of the fastest UPS modes I have tested on the channel. For my testing, I had a micro desktop workstation running a stress test in order to push the internal power supply to its limits. I also had a 24-inch LED monitor and my studio lights running off the power station inverter so we could visually see the swap over. I simulated 4 different power outages by unplugging the power station from the wall. All 4 times the PC was still running after it was unplugged, meaning the transition to battery power was very smooth. These were excellent results compared to other UPS power stations I've tested on the channel, so you can definitely count on the UPS mode of the F2400. In my next test, I wanted to see the quality of the power output we get from the F2400 inverter. In this test, I like to push the inverter to its max load for 15 minutes to see if it can handle the full rated output without overheating or turning off. Once I started the test, I was pulling around 2400 watts continuously. Using my oscilloscope, I was getting a pure sine wave output at 60 Hertz. It did have a little bit of distortion on the sine wave. Using a voltmeter, I was showing 108 volts output, which is fairly close to the rated output of 110 volts. Once the test had been going for about 10 minutes, the power station fans kicked up to their highest speed. When testing the loudness of these fans, I was getting around 59 decibels at 3 feet away, and here's a demo of what the fans sounded like. Now just be aware the fans aren't that loud most of the time. This was only under the full load of 2400 watts. Coming to the end of the test, the power station was able to run the max load for longer than 15 minutes without an issue. Now I continued to run a 2400 watt load on the inverter and I wanted to see how well the power station was dissipating heat. I recently purchased this thermal camera to see those results. So throwing some pictures up on the screen, you can see the warmest points of the power station were where the exhaust fans were blowing out the hot air and on top of the storage compartment. I feel that the fans move enough air to keep the power station cool even when it's running under max load. A small portion of my viewers run sensitive electronics, so I also like to test for noise or interference that the inverter may put out. Using my dirty electricity meter, it was maxed out at plus 2000 millivolts of noise when the inverter was enabled. I've also noticed that with it reading over 2000 millivolts, you'll hear an audible buzz on sensitive devices. To listen for that noise, I plugged in my guitar amp into the inverter, and you could tell that there was noise coming from the inverter. This noise could be a problem if you're trying to run radio equipment off the inverter, but most other devices shouldn't be affected. The final tests that I completed on the F2400 were both the AC capacity and AC idle tests. When draining the power station at a 0.2C rate with the AC inverter, I was able to pull 1650 watt hours of capacity in one complete discharge. These results were definitely less than what I was hoping for, because 1650 watt hours is only around 80.5% of the advertised capacity. When comparing this to other large power stations that I've tested, I'd like to see at least 85% of the advertised capacity, or right around 1740 watt hours. What about the amount of power that the AC inverter uses as it sits turned on and idle? I started with the power station at 100% state of charge, and I left the inverter enabled for 8 hours with no load, and when I came back, it was sitting at 88% state of charge, meaning the inverter had used around 12% of the battery, or about 1.5% per hour. This is right on par for this size of battery and inverter. Now, summing up the results of the AC inverter testing, I was very impressed that we were able to get the 2400 watts output. It didn't overheat or shut off. Also, very impressed with the UPS swap over times. Other power stations have failed where this one did a great job. Now, because this is an affordable option, it's not perfect on everything. We didn't hit the full 85% of the advertised capacity, and we also got 110 volts, which is what it's advertised to have, but I always like to get 120 volts output for full power, and we did have a little bit of noise on the AC inverter, so just keep that in mind. With an affordable model, you do have to give and take because you save quite a bit of money. Now, in the next part of the video, I want to talk about all the outputs on the front of the power station. This has 16 ports to connect your devices, and a lot of that is on the front with your DC and USB ports, so let's go ahead and take a closer look at that. Now, to charge up your mobile devices, you have quite a few USB ports to choose from. On the top, you have 2 USB-A quick charge ports. In the middle here, you have 2 USB-C ports. Each one's rated at 20 watts power delivery. And then on the bottom, you have a 100 watt power delivery port and a 20 watt power delivery port. You can turn on and off the USB ports by pushing this button here. Now, if you're wanting to power 12 volt appliances, you'll plug them into these ports here. You have a 12 volt cigarette plug that's rated at 10 amps. You have 2 5521 barrel connections underneath that. And then you have your XT60 port that's rated for 25 amps output, and you turn on and off the DC output by pushing this button here. The first thing I checked on the F2400 was to see if the DC output was regulated. This means the output voltage stays the same no matter what state of charge the power station is. When I plugged in my battery tester, it was showing 13.5 volts, perfect for running any of your portable gadgets. In the next test, I tried to pull as much power as possible from each of the available 12 volt outputs. On the 12 volt cigarette plug, I was able to pull a little over 155 watts, and connecting to either of the 5521 barrel ports, I was able to pull around 100 watts from each port before they would shut off from being overloaded. Now, I love that this also supports a high power XT60 port up to 25 amps. For this test, I pulled out both my battery load testers, connected them together in parallel, and turned up the wattage. I was able to get almost 330 watts continuously from that high power XT60 port. This is very impressive since most power stations only support up to 150 watts maximum. I then moved on to testing all 6 USB ports on the FossiBot 2400. This power station supports 4 USB-C power delivery ports, and I was able to get rated power from each one. For example, I was able to charge my EcoFlow River 2 Pro at 100 watts input, and both my other power stations were able to charge at 20 watts each. I also had my phone plugged in and charging off the last USB-C port, and it was charging rapidly. For the last 2 USB-A ports, I plugged in my favorite USB fan and a portable LED light, and both worked great. With all these USB ports in use, it was around 150 watts total. In the next test, I wanted to get an idea of the maximum output that the power station could handle with both the 12 volt outputs and the USB ports charging multiple devices. I connected up both battery load testers and all the USB ports at the same time, and I was able to pull almost 500 watts continuously from the power station DC output. Super impressive results, and the fans during this test hardly ran at all. Some budget power stations will automatically shut off the DC output only after a few minutes if your load isn't consistent. This can be a problem if you're trying to run CPAPs or 12-volt fridges overnight. To see if this was a problem on the F2400, I plugged in my Iceco Go20 12-volt fridge into the 12-volt cigarette plug, and I came back after 24 hours and the DC output was still on and the fridge was still running. The battery had only dropped down to 77% during this test, meaning you get a very long runtime while using a DC fridge on the F2400. Now, the final two tests that I completed on the DC output were capacity and idle power usage tests. The F2400 is advertised to have 2,048 watt hours of capacity. While draining the power station completely down via the 12-volt socket at 10 amps, I was able to pull a total of 1,615 watt hours over a 12.5-hour time period. These results were about 78.8% of the advertised capacity. This is somewhat normal on larger power stations since they have to regulate the 48-volt battery down to 12 volts. In my final test, I like to see how much power the DC output uses while sitting idle, while left on for a long period of time. I call this the DC idle test. I started the test at 100% state of charge, and checking in 8 hours later, the power station was sitting at 95% state of charge, meaning the DC output is very efficient and only uses 0.6% per hour while sitting enabled with no load. Now, summing up the results of the DC output testing, this is where this one really shines. The 25 amp dedicated output, it allows you to power a lot of different 12-volt appliances, fans, compressor fridges, CPAPs, diesel heaters, you name it, you can power a ton of different things off the DC output ports on this power station. I was also impressed with the idle standby losses. Even though this has 25 amps output, it didn't use that much power as it was sitting idle. So overall, very impressed with the DC output testing on the power station. In the next section of the video, I want to cover all the charging options for the FossiBot 2400. And on the top, there's actually a storage compartment that holds all the charging cables. First, you get a 12-volt charging cable to charge up in a vehicle or off a battery. You also get a solar charging cable with MC4 connectors. And lastly, you get an AC charging cable that is about 6 feet long. On the side of the power station, you have two charging ports. The left charging port is designed for internal AC charging, so there are no bulky or noisy power bricks with this power station. The right charging port is an Anderson power pole input. It supports voltage of 11.5 volts up to 50 volts and has a limit of 20 amps. Lifting up the protective cover, you can see both of these charging ports clearly. Let's go ahead and kick off some actual charging demos. When connecting the F2400 to a 12-volt battery, similar to your vehicle 12-volt socket, you'll see around 105 watts charging input. This will take around 17 hours to fully charge the power station when it's completely empty. A small hack to speed up 12-volt charging is to take the battery's 12 volts and boost it up to 24 volts with a small boost converter. This will allow you to charge at over double the speed at 300 watts. This cuts down the DC charging speed to about 6 hours. Just a note, these cheap boost converters get pretty warm over time, so I'm trying to find a better long-term solution. Also, most 12-volt vehicle sockets are not rated for this much power and you'll blow a fuse. Using one of these converters will require a direct fuse connection to your starter battery. Next, I wanted to test the solar charging input on the F2400. Remember that the MPPT charge controller supports up to 50 volts input, so I decided to test with 4 of my 180 watt solar panels in a 2S 2P parallel series configuration. When connecting the solar panels to the power station, I was seeing a little over 500 watts charging input, which is slightly above the advertised max charging speed for solar. This will take around 4 hours to fully charge if you are able to get consistent, clear solar conditions. Now, the fastest way to charge the battery is by connecting to an AC power source. The F2400 supports 1100 watts supercharging. This fast charging will get the power station full in about 2 hours. One thing I noticed while charging is that the fans are very quiet and they don't run very often. You can also adjust the AC charging speed by turning the silver knob next to the screen. You can choose 900 watts charging, you can drop it down to 700 watts charging, you also have 500 watts charging, and the lowest is 300 watts charging. Remember, charging at lower speeds puts less stress on the internal battery and will give you more charge cycles down the road. I wish every power station had adjustable charging. In my final charging test, I wanted to see if the power station supported charging via the 100 watt USB-C power delivery port. When I plugged in my Kaval 100 watt charger, I did not see any charging input, meaning that the 100 watt port is not bidirectional. What about dual charging? When I plugged in both AC and DC charging sources at the same time, I was able to max out at 1600 watts charging input. So the F2400 does support dual charging and will charge from 0% up to 100% in only 1.5 hours when you use dual charging. I also wanted to test pass-through charging, or the ability to charge and discharge the power station at the same time. In this test, I had the DC output, USB ports, and AC inverter all enabled at the same time while charging the power station. So it does indeed support pass-through charging. Well, now that I've covered the charging basics for the F2400, I want to go ahead and cover a few other things before closing out the video. Now on the front, you have a diffused LED light, you have a bright mode, and then you have an SOS mode in case you have some sort of emergency, and then you have a strobe mode just in case you want to get someone's attention. I always like when these have a built-in light because you never know if you're going to need it. The other thing that FossyBot mentions is this has a level of water resistance. They don't mention IP rating, but it has these two flaps here. So whenever you're using the power station, you want to make sure these flaps are open, but you have the ability to close these flaps and also close all the covers on the front, and it can resist splashing of water without damaging the power station. Now, last year I was using a large power station like this, and I took it out camping, and when I brought it home, I actually had it sitting next to me and a spider crawled out of the power station. So probably another benefit to these covers, when you're not using the power station, you can close it down and maybe you can keep the bugs from crawling inside. But pretty funny when that happened to me. Also, FossyBot mentions in the owner's manual, this has a 2-year warranty. You can reach out to their technical support via the information in the owner's manual and also on their website. Now I know some of you are wondering, well, how did the FossyBot 2400 do in my power station grading system? Now if you guys aren't familiar with the channel, any power station that I test, I have a grading system that I track all the performance features and if there's any issues, and it gets a score out of 10 points possible. Now all this information is tracked in an online spreadsheet I'll include down in the video description, so you can refer back to that if you want to see how this stacks up against other power stations that I've tested. Now for the score of the FossyBot 2400, I'll go ahead and throw up all the criteria on the screen. Basically, it lost a half point because it had 110 volts output and a bit of noise on the AC inverter. It lost a half point because this does not have smart app connectivity, and it lost a full point because we did not get 85% of the advertised capacity. We were only able to get 78.8 on the DC output and only 80% on the AC output. So once again, it got 8 points out of 10 points available, which is a very respectable score, especially for the price of this power station. If you want to see how it stacks up against all the other power stations I've tested, make sure you check that out down in the video description. Now in the final section of the video, I always like to do a pros and cons, because if you're sitting on the fence, maybe it'll push you one way or the other. Now there's definitely quite a bit of pros about this power station and just a few cons. So let's go ahead and break that down. Now the first thing that I really like about this power station is the lithium iron phosphate batteries. They're safe, they're going to last a long time. They're rated at 3,500 charge cycles. Now there are still companies coming out with lithium NMC batteries. Jackery. But you know, you don't have that problem with this one at all. The other thing that I love about this is the huge inverter on this, 2400 watt output. Whatever appliance that you have at your house that plugs into a standard wall outlet, this will be able to power that. I like that this has fast internal wall charging. It also has the adjustable charging up here, and because of that, it also features UPS functionality with the 8 millisecond swap over time, so very fast there. You guys saw from the testing, didn't see any issues at all. Now I also like that this has the 25 amp DC output, basically doubles the power of DC output versus some other power stations on the market. And the last thing I like about this is just simple to use. There's no complicated features. Anybody that's new to using a power station will be able to pick this up and just start using it. Now there are a few cons about this power station. The first con that comes to mind is the fact that we did not get the full 85% of the advertised capacity. We were only able to get 80%, so definitely a con there. Also, this does not have smart app connectivity, so kind of depends if those are deal breakers for you or not. Now, I'd love to get your guys' feedback on the FossyBot 2400, so throw a comment down below. Let me know what you guys think about this power station, its price point, feature set, things like that. Now, if you guys like the video, please give me a thumbs up, and if you haven't subscribed to the channel, I invite you guys to subscribe so you don't miss out on any future videos. Thanks for watching. We'll see you guys in the next one.